Okay, so we're looking at the problem set and trying to determine which one would be the easiest one to do. Just giving a quick look over. Again, I'm not always say this works, but some problems do look easier than others. Some look difficult. Um, I was looking at it. I might think one looks easy to do. It looks like they're just talking about some numbers here, and it says Bobby and Ellie have a secret 5-digit code. So I'm going to put down that B represents Bobby's number. And I can say E represents Ellie's number. All right, what does it say? It says Ellie's number was smaller than Bobby's. So that means E is smaller than B. I read that part. The sum of the numbers, well, let me write this down. B plus E is 50581. And the difference, what does that mean? I had to do B minus E, and the difference is 12965. Let me make sure I copy the numbers right. 50581, 12965. Now, what's interesting about this is two equations, two unknowns. Pretty easy to do. You get 2B. Let's add this together. You get 6, right, because 5 plus 1 is 6, and then you get 14. I'll carry the 1. 8 plus 6 is 14. That's going to be 15. I'll carry the 1. 2 plus 1 is 3. And 1 plus 5 is 6. I want to try to figure out what B is, though. I'm going to do a division here. So 2 goes into 6, 3, 5, 4, 6. Well, let's see. 3, that would give me a 6. Let's see, we subtract it nothing, and I drop place down 3. Well, 1 times 2 is 2, which is less than 3. I get 1, 5. And let's see, 7, right? 7 times 2 is 14. I'll drop a place down. Let's see, 7 again. That's 14. And then the 6 comes down, 3. So what do I know? I know Bobby's number. Right, what's Bobby's number? 31773. And now I want to see if I get Ellie's number. Now, certainly I'm going to erase my baby arithmetic over here. And I realize some people say, do you really need to do that baby arithmetic? Whether I need to do it or not is incidental. What's important is that you're able to do it yourself. And again, when I say this, in your head, on a piece of paper, on a calculator, whatever. All right? So I want to see if I can figure out what Ellie's number is. And the way I'm going to probably do that is look at, I don't know, probably, what's easy? Probably this one here. So to do that, I realized that I got to take Bobby's number and subtract it away from 12965, and now we get minus A. Well, I'm going to do something a little bit different. I'm going to do 31773 minus, right, 12965. Well, I'm going to do some borrowing. Here's a 6. This would be 13. That would be 8. 6 from 6 is 0. That was easy. I got the bar from the 1. That makes that 0. And this becomes, that's a 0, by the way. Let me get my ratio. Doesn't really look like a 0, does it? 0. And this becomes 17. 9 from 17 is 8. Let's see, I got a bar from the 3, right? That would be a 2, and this would be a 10. 2 from 10 is 8. And 1 from 2 is 1. So now I know Ellie's number, which is 18808. All right, now what does it say now? It says over here, when each entered her number in a calculator and looked at it upside down. Well, you know what I'm going to do? I take Bobby's number, and look at it upside down. Now, what would it look like? This is difficult. You might turn your paper upside down, but it looks like this over here. At least I think it looks like this over here. And it looks like this over here. So again, what I do, I did this. Gee, that looks just like Ellie. All right. Now let's do Ellie's number and put it upside down. What do you look like? 8, 0, 8, 8, 1. That's a little more tricky, but this is supposed to look like Bobby. And again, this is supposed to look like Ellie. All right, that one's done. We should check, right? And yeah, I guess I did the same work, right? Yeah. All right, let's keep moving. I can say 2 doesn't look bad. Let me just erase this business over here, and we're done with it. And remember, these are recordings. You can always rewind it, stop it, whatever, watch it again. But what I do is I really summarize what I've talked about in the blue area. Hopefully talking through it helps some students. All right, so this one over here says a circle and a square have equal perimeters. Well, let me, I'm not going to say I'm drawing a great picture over here, but this is my square, and this is my circle, and the circle has radius r. So what's the perimeter of the square? It's 4x, and they say it's identical to the perimeter of that circle, and the perimeter of the circle is 2 pi r. All right, r is the radius. Then it goes on to talk about area. Well, the area of this object over here is simply x squared, and the area of this over here is going to be pi r squared. Now what they say, the ratio of the area of the circle, let me write this down, pi r squared, to the area of the square. Well, the square's area is x squared. Well, that is the ratio, but I'm noticing over here that I kind of know what x is in terms of pi r. That's going to be pi r over 2. And x squared is going to be equal to pi squared r squared over 4. So I'm going to write that down. So pi, I'm sorry, I forgot to square the pi. Pi r squared, that's the area of the circle. And the area of the square is this thing over here, which is pi squared r squared over 4. And if you were to simplify that, you would get 4 over pi for the ratio. Let's take a look, see how we did. Yep. Again, the blue area is summarization of what we just talked through. Go back over here. I'm going to get my eraser out. I'm going to plow forward. All right. I got to be honest with clocks. Clocks are really confusing problems here. But what I know looking at says 2 clocks show 8 o'clock. They both show 8 o'clock. All right. So if I looked at 2 clocks on the wall, they're both showing 8 o'clock. All right. It says 1 clock gains 1 minute each hour, whereas the other clock loses 1 minute each hour. So what I'm going to say is every hour, the hands would be 2 minutes apart. All right. So every hour that passes, they're going to be 2 minutes apart. So, if I wrote a sequence down, it would be 2. That's for the first hour. This is the first hour. That is, what I mean by that, the hands are 2 minutes apart. That means the hands are 2 minutes apart. 2 minutes apart. Now, someone says, what hand are you talking about? The hour hand. All right, I'm talking about the hour hand. All right, I'm talking about the hour hand. They're 2 minutes apart, by the way. All right, then if I go, like, for example, the second hour, they'd be 4 minutes apart. Right, that's the second hour. So I'm just going to write this down as a sequence, and I'm going to say this is A2. And then what do I get? I keep going, right? So it goes up by 2 each time, right? So first hour is 2 minutes apart, then 4 minutes apart, and then it's going to be 6 minutes apart. Yada, yada, yada. What I want to find out is, when are they going to be exactly an hour apart? which would mean 60 minutes. Well, each hour, they're 2 minutes apart. So it would take 30 hours to be 60 minutes apart. I'm sorry, an hour apart. All right? So we're talking about the hour hand, by the way. The hour hands are 2 minutes apart on the first hour. Second hour, they're 4 minutes apart. And again, when I'm talking about the hour hands, I'm looking at this over here, the hour hands, how they're apart. All right? The hour hands are apart. All right? So by 30 hours, this is 30 hours. They're 1 hour apart. All right? 1 hour apart. So 1 hour apart. All right? 1 hour apart. Now, that they're not agreeing a time at that point. But what I really need to do, this is the tough part, right? Because what I need to do is I need them to have the same time. So when's their time going to be identical? How many hours later? Well, I hope you realize that for them to have identical, I really got to have them 12 hours apart. And what would that occur? Well, I'm looking at this, and so when you get 30 times 12. And that would give you 360 hours. So it would take 360 hours for those things to be back in agreement. All right, let's take a look at the key. Mistakes happen. And by that I mean I want to kind of look at it. So it says over here, each hour, the two clocks will be out of sync by 2 minutes. All right? They're not agreeing, by the way. The hour hands they're representing a 2 minute out of sync thing. In 30 hours, they'll be 60 minutes or 1 hour apart. What are they exactly? 12 hours apart? That's when they're showing the same time. That's going to be 12 times 30. Yep, I got 360 hours. All right, so I got number 3. I'm going to go back over here. And I think I want to do number 4 now. I'm going to erase this business over here. I'm just going in order. You know what? Number 4 looks tough. I'm going to go number 5. Number 5 says there's 49 consecutive integers. So I'm going to write that down for you. So x plus 1, x plus 2, yada, yada, yada. And it's going to be 49 of them, right? So it's going to be x plus 48. Right, that's going to give me 49 consecutive integers, provided x is an integer. Now, if x is an integer, that's not going to give consecutive integers. All right, what do they tell me? They tell me something about this. They tell me the sum of these guys. Well, I think I should write that down now. So it's going to be x plus 1 plus x plus 2 plus yada, 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 up to x plus 48. And they tell me that's equal 7 to the 5th power. They also give me the expansion of that. Either number's fine. 7 to the 5th is easier for me to write down. But I may use this later. I don't know. I'm going to try to add that together. And what do I notice over here? There's 49 terms, right? So, 1, 2, 3. This dot means there's something in there. And eventually get this one. So there's going to be 49 x's. Whoops. Got to put the 9 there. There's going to be 49 x's there. Then there's going to be an addition of 1 plus 2 plus 3 plus yada, 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 all the way up to 48. And that's going to equal 7 to the 5th power. Well, I got to keep doing this. This is 49x plus, well, I know there's some of the integers. And there's, 48 there. N plus 1, which is going to be 49, over 2. And that's a pretty simple sum formula. You may remember. You may have to derive it too. I don't know. Now, I'm gonna try to make the numbers a little bit easier for me. And the first thing I notice is that 2 goes into 2 once, and it goes into 48 24 times. The next thing I noticed is both sides are divisible by 49. So I'm going to divide both sides by 49. What do you get? X, right, plus 24. And if you divide the right side by 49, you're going to get 7 cubed, because 49 is 7 squared. All right? Now I got to do 7 cubed. And again, if you can do it quickly, please do it quickly. But I know 7 squared is 49, and then I got to multiply by 7. And 7 times 49, I would actually say this 350 minus 7. So I'm going to say 343. And then I'm going to take 24 from both sides. And what do you get? X equals, let's see, that's going to give me 319. Well, you know what? I don't know what the question is. The question is the sum of the 49 consecutive integers. I just did that. Oh, what's the median? Well, here comes my trouble now. I know what X is. I got to get the median. So someone's going to say, you know, where's the median, or what is the median? The median is the dead center. All right, so not that I want to write all these down for you, but I hope you realize there's 49 of them. All right, so I'm going to say there's A1, A2, yada, yada, yada. There's someone in the middle, blah, 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 blah. And then it's going to go to, you know, A48, and then A49. I'm trying to find this guy in the middle over here. And, you know, looking at it, I want to put out, you know, I'm going to say, you know, like A, let's put down 24. Let's see if that does it. What would be over here? A23. What will be over here? A25. All right, now, median means there's going to be an equal number down there and an equal number over here. Well, let's see. 23 minus 1 is 22, plus 1 is 23 terms. All right? So it's 23. Let's do this one. 49 minus 25. It can be 24. Nope, that's not doing it, isn't it? I got to change my mind here, right? Let's change our mind. Let's erase this over here. Let's put this down. Let's put well, I had 23 there. I'll put 24 now. And then I'll put A25. This would be A26. You get the idea, right? Try and get that median turn over there. 24 minus 1 is 23. So now it's 24 terms here now. 49 minus 26, right, I'll write this down for you, is going to be 23. 23 plus 20 is 24. So now I know it's A25, all right? So what I want to convince you is that I think I can figure that out without counting there. And the way I do that is, you know, this is X plus 1, and this is going to be X plus something, right? So I want to point out it's really just 1 less than the index. So it's going to be X plus 24. All right? Let me write this down now. What's X? It's 319 plus 24. And 9 and 4 is 3. Let's say 13, I should say 13. And then you get 4. So I'm going to say 343 is the median. Let's look at our work. Yeah, we did. This is number 5, right? 343. All right? And the work is down, by the way. All right, I'm going to do the next one. And I got to be honest with you. I can understand, like, looking at it and not knowing where to begin. I always said the best place to begin is just writing things down. And that can be really tough, by because writing it down might be super frustrating. Right? In other words, you write it down, you don't see anything. And I am guilty of this many times, writing things down, and I don't see anything. But I'm going to write this down. So I'm going to write down, you know, S, whoops, let me get my pen out. S is a sum. And let's write this down. I'm going to say 1 factorial plus 2 factorial plus 3 factorial plus yada, yada, yada. And I just copied it, all I've done. All right, I'm going to do something that might seem really crazy. I'm going to do something really crazy here. I'm going to let's write this down. 2 times 1 factorial plus 3 times 2 factorial. I think this is too big though, right? 4, 3 factorial plus yada, 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 up to, what would I get there? That would be n plus 1 times n factorial. But I hope you realize I got to take something away now. And what am I going to take away? I got to take 1 factorial, minus 1, 2 factorial, minus 1, 3 factorial, minus, this is going to be 1 n factorial. Let me point out what I mean by this. If you look at this identical to this term. If you look at this, identical to this term. If you look at these two, so forth and so on. I think you can probably see that. But again, this might be another dead end. I don't know. Let's write this down. S equals, well, let's be very careful. This is really just 2 factorial. What's the next one going to be? 3 factorial. What's the next one going to be? 4 factorial. I'm just doing these guys, all right? Plus yada, 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 up to n plus 1 factorial. And we're going to subtract these away. And what are these guys going to be? Well, minus 1 factorial, minus 2 factorial, minus 3 factorial, minus 4 factorial, minus yada, 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 minus n factorial. Well, I'm starting to see things now. What do I see? I got to be careful here. And what I see over here, my red pen out, I see a lot of cancellations now. Now, I hope you realize this guy here would cancel the one prior. Then the big deal comes, what's left over? Let's write this down. What's left over? Well, I definitely see n plus 1 factorial. And then I see the thing that I have not accounted for over here, which is just simply minus 1. That's a sum. Let me get my ratio. I didn't mean to box the S. Let's see if we did it. All right? And mistakes happen. Right here. All right, we got it. All right? So, n plus 1 factorial minus 1. So I think we did okay. And, certainly I'm going to say, repeat this. This was actually not a bad one. I mean, I'm going to say the easy questions here, 1 was easy, 2 was easy, and 5 wasn't bad. The tough questions for me, I'll be honest with you, on this one would be these two. These are the tough ones, right? And part of the reason I just don't like clock problems. The other reason factorials can be a nightmare to figure out. But anyway, we got it. All right, remember, if you need to reach out to me, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And let me repeat this. These are not very popular videos people are watching, and there's very few people watching these videos. But if I'm getting, at some point, if a lot of people start watching these things and they want to ask me questions, I just can't do it, all right? But if few people ask me questions, I can answer your questions, all right? But do feel free to reach out to me. Whether I get back to you or not might be a different story. But if I'm not overwhelmed with people asking questions, I will do my best to get back to you. I do thank you for paying attention, though. Thank you.